I think I'm sure they're going to be shot anyway. I can't imagine it was just air on the side. What's that? Okay. Not sure. It's hilarious. I'm here with Josh Leander of Colorado Analytics. I posted, maybe a week ago to the acoustics subreddit. I had an acoustics question, which is that this soon-to-be shop is super reverby and boomy. And Josh, you offered to come up and measure it with all your fancy equipment and help me come up with a real plan as opposed to the really crappy plan I started with.
We're gonna set this sound level meter up inside.
Okay.
And we're gonna move it around to a couple different places, and in every spot, we're going to excite the room with an impulse sound source. So yeah, you just go as big as it'll be comfortable doing.
Okay.
It'll let you do it.
I haven't blown up a balloon in a long time.
What's the altitude here?
10,000 feet.
You're gonna get lightheaded a lot quicker.
Yeah. Although I don't know if blowing up balloons would do it, because you're still taking in a lot of oxygen. Definitely other physical exertion, really.
Yeah.
You really feel it.
Yeah, well, I'm already lightheaded, so I'm gonna blame it on the balloons. Yours are much bigger than mine.
Oh, right. Well, you said as big as I could. Well then.
I had no idea that could happen. What happened?
I don't know what's going on.
We'll be off the floor.
Yeah, let's try that. There is a lot of silica dust in here. The other thing we could do is bring the compressor up here.
It's worth a shot.
And fill them as we go. Come on, let's go. Load up. Load up. You're making this difficult. All right, load up. Oh, hang on. Hang on. We gotta get the other attachment. Okay. We needed the attachment, which I think will work for balloons.
Do something kind of central.
Okay.
This room is so echoey that it almost doesn't matter where we put it. You're gonna want to hold it away from your body as much as you can. Awesome. Okay.
That was really cool. That's so cool.
As far as measurements go, we've got that. I can't look at the results yet. I have to download it first. But while we're measuring, we can look at background noise that we get from your
That sounds
HVAC.
great. You want me to kick that on?
Yeah, if you have a way of putting it on full blast,
Yeah.
do that.
There it goes. This is kind of your specialty, right? You're not so much on the like recording soundstage side of things.
Right. Yeah. This would be an example of room acoustics.
Yep.
But like more often, it's we're industrial noise control.
So factories.
Factories, a lot of manufacturing, like heavy industry, worker hearing conservation.
Yep.
And in this display, you can see all the different frequencies.
Yep.
So you can see this peak right here. So this is going to be directly from your machine right there.
Okay. So that's your sound source.
Now the fact that this room is so echoic makes the levels go up.
Right.
So after you treat it, it's going to be quieter, but this will still interfere with your recordings possibly.
Okay. Well, is the next step to download this to the computer? And
Okay. For most of my career, this has been worth more than the car that I drive.
Oh my God. What does one of those run?
Like this is an older one.
Yeah.
But like new with all the software, with all the bells and whistles, it's going to be like 8,000, 10,000. It's crazy.
Where does you had measured roughly 60 dB for the air handling.
Yeah.
Where does that sort of stack up in terms of like, what would you want it to be, I guess?
Significantly less, 45, 40.
Yeah.
For recording, 30, 35.
Okay.
So what we're measuring is called RT60. So that's reverberation time, and that is the time that it takes for the sound to decay by 60 dB. And so ideally we want a nice even spectrum where you have approximately the same decay speed in each of the different octave bands. So.
And that makes the room sound more natural, like less, either boomy or tinny or...
Yeah, exactly. So you don't have specific frequencies that are sticking out and just making things sound weird. Yeah, so we can compare this against the model that we were making.
Yeah. So you had me come in and fill in room dimension. I put together the square footage of, where is their drywall, where is their glass, that kind of thing for each of the walls. And then you also have a way to adjust how much treatment you're giving to each area.
Yeah. So because if you put a panel up, it's going to cover part of the wall.
Yep.
So you want to adjust your...
Yeah. So now what we're doing is dialing in what we're guessing the glass and the drywall are absorbing.
Yeah.
To kind of make this match the measurements.
Right. So we can get like closer agreement.
Yep.
And this isn't strictly scientific, but we don't really need it to be.
This whole idea of doing measurements and then matching your model to that it almost seems like it shouldn't be possible.
Yeah.
Particularly because the model, at its fundamentals, is very, very simple.
Yeah, right. There's just like a lot that goes into it, and the model just really takes into account the basic dimensions of the room and the amount of surface area that you have of each type. Yeah. So it is pretty simple. So we've been sitting here chatting, and I think we have a treatment plan.
I had originally talked about doing 2-inch acoustic blanket on the ceiling, and it seems like that's actually pretty helpful. But the issue, and you had alluded to this when we first started talking, is that it might not do enough on the low end of the frequencies.
Right.
Your recommendation was doing 4-inch foam, which will absorb more at the low end. Same amount at the high end, but more at the low end. And do that and kind of sprinkle that around on the walls.
Right, yeah. Because it's thicker, it can affect lower frequencies.
Yeah.
Because it literally reaches out further into the sound wave.
Yeah. And so we've kind of got this model, we'll show it on screen, but we've got things down to the 0.8 mark above 500 hertz and above, and then down to 1 second or so at 125 and 250.
Yeah.
And then you were kind of saying off camera that's kind of good enough at the low end.
Yeah, no, that's actually really good.
Okay.
Yeah.
Okay.
That's sweet. That's really good. I think it's going to sound really nice and natural in there. It's not going to be boomy. It won't really sound like you're in a shop, I don't think.
We're coming in, I need to go back and run the numbers again, but budget-wise, we're coming in around, I don't know, $5,000 to $6,000 here, kind of in materials, which is where I was hoping to end up. So it's going to work. Obviously, I don't have I can't throw $30,000 in sound treatment into this space. And it seems like all of this stuff is kind of additive. So we're starting with a good plan for the overall room.
Yeah.
We'll get there. We'll measure it, measure it again, see where we're at, and just see like subjectively too where it's at, and then can add more stuff if needed.
Right. Yeah. The inner measurements, we could see that casing radiated sound coming off of the furnace.
Yeah.
Pretty strong. So we do know that you want to treat that. But once that's done, the rest of it is you'll know if you're happy or not.
Yeah. Awesome. Well, thank you so much for coming up here. This is a day trip for you, so I really appreciate you coming out.
Yeah, there are worse days than driving up to the mountains to do acoustics. Like,
Fair enough.
It's been a really nice day. So.
Well, I appreciate it. Where should people go if they want to talk to you about your services for industrial sound treatment?
Yeah, just go to the website. That's coloradoanalytics.com.
Awesome. Well, thank you so much.
Yeah, thanks for having me.
Right. As I mentioned in the previous video, I'm giving away a Bamboo A1 3D printer, complete with an automatic material system for automatically changing filament. I love it. I have a brand new one in a box to give away. I finally have everything set up for the giveaway, so head to strangeparts.com/A1C giveaway to sign up. It takes just a minute, and I'll be announcing the winner in an upcoming video. I'll talk to you soon.